Hello, grade 11. In this lesson, we'll talk about transformations of function. This is 1.7, page 73. We'll take one example, which is the parent graph of the absolute value function. You know it, this one, the red one. We studied in the lesson before. And we will see the transformation of this function from the parent graph itself. So y equals absolute value of x is the parent function, the red one. And the transformation of this parent graph are: number one, if you add or subtract a number in addition to the absolute value of x itself, this makes shift up or down, c units up or c units down, like this one. This is y equals absolute value of x plus 1, means you rise it up 1. So it's shift up 1. If it is absolute value of x minus 1, it will be here in this position. And number two, if you produce a transformation inside the bracket itself, it will be x plus or minus c absolute value. This will make a shift left or right, c units left or right. So if it is plus, it will be a shift left, minus, it will be shift right. So for example, this one, this is a shift right, so it will be y equals absolute value of x minus 1, but inside the brackets. Number three, if there is a negative sign here, that makes a reflection on the x-axis. Reflection on the x-axis, it will be like this. Number four, y equals c absolute value of x. If this c is a number greater than 1, it will make something called vertical stretch or narrowing. Like what? Like this. Look at this one. It goes very close to the y-axis according to the number, because there is a 5 here. If this 5 is 6, it will go much closer to the y-axis, shrinking. But if this number c is between 0 and 1, means it is a fraction like half, 1/3, and so on, it will make something called horizontal compression or widening. Widening means opening the curve. This is number 4, number 5. Number 6, if there is a negative sign inside the bracket itself, this will be a reflection on the y-axis. In this example particularly, the reflection on the y-axis does not make any change, because this branch will come to this branch, so it doesn't make any change. But for other functions like the absolute, the radical function or the cubic function, it will make change. Means the left side will come to the right side and the right side will come to the left side. So if there is a negative sign inside the brackets itself, so it will be a reflection on this y-axis. In exercise page 78, you will do this number 7, 15, 17, up to 31. I'll take some. In number 34, describe and identify the parent function and describe this sequence of transformation from f to g. The parent graph of this function is f equals x squared, this one, the quadratic function. And for gx equals negative 1 over 4x plus 2 squared minus 2, I need to know what are the transformations happen to this one. This negative 2 makes shift down 2. and this plus 2 makes shift 2 units to the left, and this negative 1 over 4. The negative makes a reflection on the x-axis, and the 1 over 4 makes horizontal compression. Horizontal compression means a widening. It will be much wider. So the gx will be here, means you go to the left 2 and go down 2, and then this will be the vertex, and open the curve like this, because it will be much wider. Okay, number 16. In number 16, fx equal x power 3, the parent function fx equal x power 3. In number A, I need to write the function notation of this curve. You can notice that this curve is reflection on the y-axis of this curve, and it is shifted up 1. Reflection on the y-axis means you change inside the brackets, the negative sign inside the brackets, and shift up 1 means plus 1. And for this curve, you can notice that this curve is shifted to the right from the parent graph and down 4, so it will be minus 4, and it is shifted to the right. This is a number D. Shifted to the right at 7, so the graph will be not this one. I can say it is minus 4 here, and shifted to the right will be x plus minus 7, because it is shifted to the right, cubed, and it is shrinked. You can make a fraction here, like less than half. Let's say half. So this will be gx. This is the way to write the function notation. If you see the graph, you have to identify the transformation left to right and the shrink and the reflection, so that it appears in the function notation. In number 22, you have this graph, and I need to write the function notation of this graph. This is a step function, but the normal step function, the parent graph of step function will be here, starts from here. But this starts from 4, means it is shifted up 4. So the function notation will be y equals step function x plus 4. In number 26, you have the function notation and identify the transformation. This is the function notation. I need to know what are the transformation habit from the parent graph. This is a quadratic function, means fx equal x squared. This is the parent function. And what happened? It is shifted to the right 8 units, only that. So the transformation is shift to the right 8 units. Your practice, as we said, these numbers in page 78, and your project is one word problem.